Hello and welcome back to another episode of Effective JaRu, the series where we read effective Java and try to port the items into idiomatic Rust if possible. So we are in chapter 5 that is all about generics. Item 28 tells us to use bounded wildcards to increase API flexibility. So bounded wildcard, that's the guys with the wildcard type parameter basically is this question mark, right? Where is it? Here, that. And the bound means that we say, well, it should extend something else. And that is it. So basically we say that we support everything that, let's see, is this something? No. Is this something? No. We support everything that where T is a superclass, for instance. So there's this rule, if I remember correctly. Unfortunately, this doesn't actually work. If you try to build that, then it will show a runtime exception because for some reason Rx is empty or too empty, and this just crashes here. Well, anyway, this was expected. It's kind of the same thing that we have seen before, but with broader bound. And all this does basically is to say that you support everything that is T, or where T is a superclass of. I think that's really it. Whereas here we say we support everything where everything that is T or that is a subclass of T. This is what we say. So how does that work in real life? I think the example is not really shown here. It doesn't look like it. So there's probably a better example, maybe reduction. So all the files you've seen here is basically the existing stuff, but extended so that you see how these wildcard bounded type generic types blah parameters blah blah work. And in Rust you don't have that really, not really. You don't have that because all you have is traits, and you basically in a horizontal fashion say which traits you need supported. So there's no inheritance, right? And because there's no inheritance, something like that you cannot even specify. Interestingly, it's not less flexible. I never miss the inability to inherit something per se. You can basically combine trait requirements and say, well, my trait requires these other traits to be present as well. So that's kind of a dependency chain that you can then define, which is cool and nice, but I never, needed more. I was always happy. So this complexity basically comes in because of that. And there is this, let's see if there is a rule here. There's this, I think, specs or packs rule. So if there are producers, then you want to say, well, wildcard extends T, and if it's a consumer like comparable, we might not have it here, then it's wildcard super T, and that's kind of the rule of thumb here. So if it's a producer C, then it's always extends. Otherwise, it totally makes sense if you think about it. If you break it down to what actually happened. It's like 35 degrees here. My computer is unhappy, and I'm also unhappy. But let's make sure the mind doesn't realize that by confusing it with Java generics. So, what else is there? Is there anything interesting that I really want to show? Oh, for maximum flexibility, use wildcard types on input parameters that represent producers or consumers. I've seen this rule of thumb here somewhere here. PAX stands for producer extends consumer super. I'm not sure if that is a great thing, but PAX is something you can probably remember. And so far, as I've talking about it, I think I might even remember that stuff. It's not difficult. I think it's actually easy, and there's not so much to it. It's also good to know that you can say, well, T must be a super type of whatever comes in there. And that is for consumers only. So let's have a look at more code, maybe find some code that we actually want to implement in Rust here. As Rust doesn't have inheritance, we probably have seen it all already. Yeah, so we have pop all where collection, that's being consumed apparently. So we support everything that is where E is a super class or E, right? How does it work? And we pop it into destination. Okay. So if E is a superclass, oh really? So how does it work? Pop all. Or where we are a superclass. So we have an array of number stack. We have numbers and we have an array of objects and we want to pop it on. And this works because... and this works because we are able to push. What is E in that case? E is E us? Yeah, E is number. Where this is a so where the wildcard is a superclass of E, not that we are a superclass of that. Kind of makes sense. So if this coming in as a superclass of us, then we work. Or if we are that, right? So this super also always means this wildcard could resolve to E, but could also be a superclass of E. So that makes total sense as why that works. And this is what you want to make it more flexible, to basically factor in the ability of inheritance when it comes to the class hierarchy of Java. So how would that translate to the Rust world? As there is no inheritance, this doesn't translate at all, but Rust has conversions, right? So it is possible to say, I want this to be convertible into something else. And this is something we can specify, obviously. And let's look at some standard collection item here, like vec, and see if there is something like that. I don't think so, but like a converter. Well, we have from iterator, right? From iterator is like a conversion thing. And well, it also creates a new vector of t, but what pushes something? Can we, oh yeah, extend. I think extend. Look how that works, where I is into iterator that has the item itself. So there's no conversion going on. It requires the item itself. A conversion trait, of course, it's for free if the item is already that, but it will do what has to be done to make it happen. So I think the default interface here in Rust wouldn't attempt any conversion. I think that can be retrofitted because if necessary, but right now it doesn't look like it. So what if you wanted to, what if you had strings that would parse to, yeah, I think the conversion is something we would do ourselves. So let's do that. Let's see how that would work. But it's kind of a contrived example. It's kind of totally made up. Because if I want to have strings here and convert them to, or put them onto a number array, then obviously this is something that would never work in Java either, because these are not in the same hierarchy like number and string. They derive from object, but that's not kind of our example here. So no, we could try it, and that would even work, but it would also be manually implemented. So I think this is a good thing to have, because then if whenever something converted, we do it ourselves, which is really easy. I might actually show it just for the fun of it. So let's have it an item 28 here. Cargo new item 28. Of course, we want to be in there. Oh, item 298, hopefully not. st source lib, there we go, finally. Test explicit conversions. So if I have a vector of u sizes or I32, let's have a vector, let's have numbers, which is a vector of I32. And the vec new in this case obviously means it's just on the stack, right? No heap involved. For the structure itself, obviously this thing will allocate, which is, you know, part of the deal. And now I can say number, let's call it numbers extend. And now we have to pass something that converts into an iterator, or is an iterator. And what I would like to do is pass in strings here and minus 3 and maybe 0, like this. Then we iterate it, then we map it, which changes the type. The map is, you know, we get some value or some string. Let's call it s. And we parse s into what is required. And type inference possibly is smart enough to realize that obviously we want to convert into an I32. But I'm not sure about this. This would be my intuition here, because type inference is really great most of the time. And parse, you know, it's a generic method whose return type is t, and it's implemented for certain types of string can parse into certain things. So let's see how that looks like, shall we? Cargo test. Mismatch. So output is I32. Oh, well, no, wait. Oh, it's a result. Sure, parse can fail. So what do we see here? Expected a result, but found I32. I think it's kind of, I would see it in an inverse way, because we wanna, you know, parsing can indeed fail. You just unwrap here to convert the result that we get from the parse into whatever there is. Cannot borrow immutable local variable numbers as mutable. True. You must make it mutable. And this actually works. I mean, we will see how it works, because we shall check for the result. So we want to be sure that numbers are equal to a similar vector of 1, 2, minus 3, 0. There we go. Oh yeah, sure. Semicolon. So as you can see, this actually works. And that's the cool thing. So conversions are really easy, thanks to the gorgeous closures there. And it's not a problem at all. Sure, if something fails here, we just fail unhappily. And I'm not sure how to handle that in such a context. Usually, you probably don't want to deal with errors. So error handling is a different thing. If you unwrap, you kind of risk a panic, which is something you wouldn't want to do. Not like that. You could of course write more code there. And the thing is that you cannot really get out of the closure. You cannot return the result, the error result, in the caller. Basically, you're kind of stuck in there, and that's something in that context will make error handling a bit more difficult. In other words, you might end up writing a real loop to be able to handle errors correctly, but I think also that is fine depending on what you're doing. And our example here just shows what you can do if you want to do. So that's kind of the conversion stuff. I think it's a good example on how Rust works. It's explicit, it has no inheritance. So there you go. What's swap doing? takes any lists and swaps this. Swap helper. Oh, yeah. I think I remember, because if you have a wildcard here and you try it yourself, the compiler will tell you that stuff is not working. And then you need a helper which will kind of infer the type that is actually in there, and that does it without an error. So that's the thing. Yeah, that's what you read in the book, at least. I think the book has an example for this. Let's bring it up. So here, private helper message. So this, trying to compile it, produces a less than helpful error message. Yeah, it's nice to see that he acknowledges the fact that the Java compiler is less than helpful. In Rust, it's explicitly said that unhelpful or bad compiler messages are considered a bug, and that's super awesome. Sometimes the compiler talks to you in Rust, I mean. It's like a conversation, a dialogue with a good friend who is much smarter than you and who tells you in a friendly way that you've messed up. And why? And what leads to the conclusion, you know? That's awesome. So here, set in capture of y in list capture blah of y cannot be applied to int object. Yeah, awesome. So probably it's because the list actually is a raw type here. It loses all type information, and then weird things happen. But then with the helper method, it kind of works again. As a workaround, an additional call in Java that costs you, huh? I don't think that can be optimized away. In Rust, you would say, yeah, come on, this gets optimized. The optimizer is your friend. But in Java, I wouldn't see that. But maybe it works, maybe it doesn't. I have no idea. I would just be cautious about it. Oh, index out of bound exception. It's this typical thing here that args might be not what he expects. But why is that? What happens here? Swap helper, array get out of bound exception. So it tries to change the first and the last. Okay, sure, there is just one element in here, right? So 0, 0 will not swap. I don't know. Okay, so what's the union saying? This is a set union here apparently, and yeah. So here we are flexible. Whatever is E or is a subclass of E, right? That's a producer. We get stuff from it, and we add things to something that will be an E, so that, you know, we boil it down, we bring it down to basically the lowest common denominator, which is not really encoded here, right? We have E, which is explicit. Lowest common denominator is nothing we can encode, probably not needed anyway. So we have numbers, integer and double, and then, yeah, we put it into numbers. That's a very, very interesting thing, because type inference does shit for you, apparently. And excuse my language here, but this is something I would totally expect to work. However, you have to use this very, very interesting syntax to say that you would like to have, I mean, honestly, when I read this, I think, okay, the union here, look at that, it's highlighting it, is a class, and I'm going to, you know, it's all about static methods here. So it's not really, I don't see that this applies to the static method at all. It looks like it applies to the type, which isn't even having a generic parameter. So that syntax is terrible, honestly, super terrible. Explicit type parameter. So yeah, let's see what happens. Let's build it. Let's see what the compiler message says. Let's see how helpful it is or not. So if you put that in, I should see a message. All right, error incompatible types. numbers. So we need set number. We found set int 1. What? Where int 1 and 2 are intersection and one extends number. What the heck, you know? That's what you feel. What the heck? I have no idea what you mean. And the other one is where number is already in use. Okay, fine. Interesting. So this is something to remember. That's kind of type hints, right? In Rust, you can provide type hints as well. If there's ambiguity, you have to provide a type hint in some way, or if there's just not enough information to infer the type. But in Rust, it's actually quite easy to do, even though it looks funny sometimes. But this, you know, Rust I can remember, I can understand. But this is something I will probably never remember. Makes no sense to me. It doesn't even look like a hint, right? So, for example, if you want to convert stuff, then you do it like this, right? That's a type hint as well, if you think about it, because you tell the compiler, I want this. I want to convert that into this. And this syntax here looks more like an inline return value declaration, which maybe is what they want, but I'm not sure why you would need the number there. Maybe you don't need it. Maybe it's old Java. Oh, hell yeah, you need it. Okay, so that is a syntax error. That was the parser Alexa hating us. Yeah, so that is that. So that's, if you learn anything, then yes, you can have type hints. You can make them, but probably you will not remember how to make them because it makes no sense, at least to me. And I'm not sure what happens if this is not aesthetic anymore, or if the type is, I don't know. Actually, I have no idea. It's very interesting though. Is that nice code? I don't think so. And I really hope I never have to write that. Yeah, probably I just want to check out the current file here and get rid of all of that. Get rid of that. So 22 minutes in, that shall be enough. One more item to go, which is very interesting. We should have a separate session for that. Thanks for watching and have a great day.